right, so for these graphing questions, you have to know the basic form of the sine curve and the cosine. Sine looks like this, right? It's the sine x. And cosine looks like this, sort of like Mickey Mouse.
Or Mickey Mouse.
Yeah, or your favorite rat or something. Yeah. Huh? Like this Mickey Mouse. Right?
Well, I'm so confused.
Okay. Anyways, so it starts at 0. 2x equals to 0, and then it ends where?
2 pi.
It ends at 2 pi, right? So you have x equals to 0, and then if you divide by 2, what do you get? X equals to?
Pi.
Pi. So once you get those numbers, then you just draw, here's 0, here's pi, okay? So you get that, you just have to, whatever that's inside the sine function or cosine function, take that and set equal to 0, set equal to 2 pi, beginning and end. And you just got your beginning and end. Is that okay? Yeah. And now, what is this point?
Pi over 2.
Pi over 2. It'll be halfway from 0 to pi, right? What will be this point? Pi over
45.
4. Yeah, or 45 degrees. Yeah. Right. So if you take pi over 2 and divide by 2, you get pi over 4. How about this point? How would you get this point?
3 pi over 4.
Yeah. So any midpoint is the average, right? So if you want the midpoint, you can do pi over 2 plus pi and divide by 2. And now you could do this computation, but the easiest way out is just to multiply 2 top and bottom. So 2 times pi over 2 will be just pi. 2 times pi will be 2 pi. And then 2 times 2 is 4, so that's going to be 3 pi over 4. Okay, so that's 3 pi over 4. Okay, so you got the important points. These are the points where the sine or cosine will be like extreme values, or it will hit the x-axis, right? Okay, so since we're doing the sine graph, I look at the sine graph, copy that over here, and we're done. Oh, we're not done yet. Okay, we have to know how high it goes.
4.
How high does it go?
4.
4, because 4 is multiplied, right? So I put 4 here. How low does it go?
-4.
-4. Okay. Oh, and then it's also asking for amplitude and period. So what is the amplitude?
4.
Is 4. It's the distance from the peak to the equilibrium, the midpoint. And then period
Pi.
is pi because that's the end, that's the beginning, right? So it's pi minus 0, which is equal to pi. Done. Any questions? All right. Let's move on to the next one. Same exact idea. What should I do?
Equal to
2x minus pi over 3 equals to?
0.
0. Okay. And then 2x minus pi over 3 equals to?
2 pi.
2 pi. All right, so this one, let's solve this. 2x equals to pi over 3 if you move it to the other side. And now if you divide by 2, what happens?
6. It'll be pi over 2 pi over 3.
No, if you divide, that gets multiplied to the denominator. So it'd be pi over 6. 3 times 2 is 6, okay? And then, now this one, I can't solve the same way because there's a fraction there and then there's a non-fraction. If you move it to the other side, you end up adding a regular number to a fraction. It's confusing, so I would rather just solve this by multiplying by 3 both sides. So I multiply 3 both sides. So that these two 3's will cancel each other. This will be 6x and minus pi, and this will be 6 pi. Okay, now what? 6x is equal to?
6 pi plus
7, yeah, 6 pi plus pi, which is 7 pi, and then x must be? 7 over 6 pi. Okay, good. So with that, I can draw the graph. All right, I should draw here, because I need room for on computation there. So you want to put some places pi over 6. That's your beginning point. Now when you draw these things, please make sure that at least your x-axis is in scale. If you chose this to be your pi over 6, then 7 pi over 6 would be somewhere 7 times this. Yeah. Don't put 7 pi over 6 right here, then I'll be mad, I'll take points off. Don't do that, okay? So what you want to do is, you say this is about pi over 6, so it's 1, 2, 3, 4, 5, 6, 7. So that point is 7 pi over 6. Okay. Because if you don't have the correct sequence, correct scale, then you may end up drawing a completely wrong graph. Okay, it's very important that you try to figure out the exact points. Now, and then you should at least find the midpoints. Okay, so how do you find midpoint again?
The average.
You add the two things and you divide by 2, right?
4 pi over 3.
Yeah. But while you can do that, the quickest method is when you have multiple fractions, just multiply top and bottom by the denominator to get rid of the denominator. So you just have pi plus 7 pi divided by 2 times 6, which is 12, which is 8 pi over 12, which is, well, they're both divisible by 4, right? So 8 divided by 4 is 2 pi, and then 12 divided by 4 is 3, so 2 pi over 3. So this point right in the middle is 2 pi over 3.
Question.
Yes?
Just to go back, so when you add the pi over 6 plus the 7 pi over 6, as long as you times it by the denominator, it should always work.
As long as this number is exactly the same as this number, it should always work. Okay. You can't do 6 and then times 3 here. It has to be exactly the same number. Okay, okay, so we have this, and then, I mean, it would be nice if you could find the midpoints again by doing the addition again, but let's not worry about that. Okay? Yeah, just too much work. But I really want you to find the midpoint at least, all right? Okay, so I have, just mark them because those points are important. So we now have the 5 points. And now you draw the cosine graph. It's like a mouse shape thing, right? Mickey Mouse or something. Yeah. Good. Easy, right? Yeah. Why did I do this? Because it's the cosine. Cosine is this shape. Yeah. Oh, we're still not done. What's the amplitude?
3.
What's the period? Well, period would be terminal minus initial. So the graph ends at 7 pi over 6 and begins at pi over 6, right? So it will be 6 pi over 6, which is just pi. So the period is pi. And by the way, it might look a little weird because the graph stops here. What's really happening is that the graph extends beyond and before. Okay? Because these are periodic graphs, so this is just one period, but this gets copy and pasted right and left, so you could continue on and continue, and the graph extends everywhere. Okay?
Does the graph still extend from 3 to negative 3?
Oh, yeah, thank you. I forgot that. Okay, so amplitude is 3, so this is 3, and that's negative 3. All right. Okay. Same exact idea, except that for this last question, the minus makes things a bit tough. What does this minus do in front?
Shifts it downward.
It flips upside down, right? It changes top and bottom like that. So instead of drawing the graph of sine, because of this minus, instead of drawing the graph of sine, you should flip this upside down, and you have to draw this one, right? So keep that in mind, right? Okay, so the same exact idea. You take 3x minus pi over 2 equals to 0. Move this to the other side. and then you divide both sides by 3. Dividing introduces that number in the denominator, so you end up with 2 times 3, which is 6. So you get pi over 6. And then 3x minus pi over 2 equals to 2 pi. Right? Always 0 and 2 pi, okay? And if you have 2 pi, it's better to just multiply. Multiply everything by 2. 2 times 3 is 6. 2 will get rid of this denominator 2. And then 2 times 2 pi is 4 pi. Move the pi to the other side, so you get 6x equals to 5 pi. And then x is equal to 5 pi over 6. Right? So, let's now draw the picture over here.
No, that's just where you start.
Okay, pi over 6. Again, it starts at pi over 6 and ends at 5 pi over 6. So try to make the ratio work out. So here's 1, 2, 3, 4, 5. So this point right here is 5 pi over 6. Okay? And then the midpoint, you get it by taking the average. But when you have a fraction inside a fraction, the fastest way to simplify is to multiply the denominator top and bottom. So that gives you 6 pi. Oh, let me just write it. So 6 goes away, so you get pi. 6 goes away, you get 5 pi. And then you get 2 times 6, which is 12. So that's going to be 6 pi over 12. And that's pi over 2, because top and bottom both can be divided by 6, and then you get pi over 2. So this point right here is pi over 2. Okay, so we're now ready to draw the graph. I erased it, but you remember what it was, right? It was these points there. It's like that. Okay, how high does it go? 2. How low does it go? -2. Okay. So what is the amplitude?
2.
Okay, what's the period? Period would be 5 pi over 6 minus pi over 6, which is 4 pi over 6, and then it's 2 pi over 3. So that is the period. Okay, so first, what is secant of theta? What's the definition of secant? Yes?
1 over cosine.
1 over cosine. And because of that, sometimes secant won't be defined. When would that happen? When cosine theta is 0. So this will be undefined if cosine theta is 0. But then all you have to invoke is the graph of the cosine. We all know the graph of cosine, right? Here's 2 pi, here's pi over 2. What is this point, midpoint? Pi plus 2 pi is 3 pi, and what do you have to do? Divide by 2. Right? This is 0. And then just draw the graph of the cosine. This is the cosine graph. We drew it several times, right? Now, when does it hit 0? At pi over 2, the value of the cosine becomes 0, and at 3 pi over 2, the value of the cosine becomes 0. So done. Pretty straightforward, right? Okay, similar idea. Cotangent is what?
1 over 10.
Cotangent is 1 over tangent, but I know that tangent is sine over cosine. So if you take the reciprocal of sine over cosine, what do you get? You get cosine over sine. Cosine theta over sine theta is the definition of cotangent theta. And now that you have sine theta in the bottom, you know that this will be undefined if sine theta is 0. This time if the... Okay. So to answer this, you just have to draw the graph of sine. Here's 2 pi, here's pi over 2, here's 3 pi over 2, here's 0, and just draw the graph of sine, just like that. When does it hit 0?
0,
here,
pi, 2 pi.
here, here. So the answer is, you have theta equals to 0, pi, 2.
What?
All right, sine pi over 3. Pi is 180 degrees. So if you divide by 3, that's 60 degrees. And I want you to be using the unit circle for all this.
Big old thing.
So here you have 30, 45, 60. And then remember the sine is the y coordinate, so it's the height, right? And we have 3 sticks for the heights. And we gave names for it, right? Small, medium, large. So small size, they all look like this. And the small one is 1, medium is 2, and the largest one is 3. Okay? All right, so which one is this one?
Large.
It's the largest one. 60 is the largest one, so this must be radical 3 over 2. All right, now let's try pi over 4. Pi is 180 degrees, so if you divide by 4, that's going to be 45 degrees. And what is secant? Secant is?
1 over cosine.
1 over cosine, so it will be 1 over cosine of pi over 4. Which means you first have to find the cosine pi over 4, and you have to flip upside down, right? Okay, so looking at the 45 degrees, what's the cosine length?
Medium.
Small, medium, or large? Medium, right? It's see if the two sides have the same length, that means it's a medium size, and the medium size is the square root of 2 over 2 one. So that's the cosine value, and since you're taking the reciprocal, you have to flip upside down, so you get 2 over square root of 2. So this is almost the answer, except that if you have the square root in the denominator, what do you have to do?
Multiply by the square.
You have to rationalize the denominator by multiplying the square root top and bottom. So you have 2 times square root of 2 over square root of 2 times square root of 2. So it's going to be 2 times square root of 2 over 2, and 2 cancel, so you get square root of 2. Okay, tangent 225.
Sine over cosine. 225.
It's 225 is this way, and you have basically 2 ways to do this. One way is to use tangent equals to sine over cosine. Another way is sometimes if it's the 45 degree one, you can easily use the graphical meaning of tangent, which is the slope of this line. What's the slope of this line when it's 45 degrees?
2. 1.
1. Slope is 1. So this is just 1. Right? Cosine 480. Oh, now this is a bit tricky. What do you do? 480 degrees.
Subtracting 360.
Right. So if you have 480 degrees, if you have something bigger than 360, you have to subtract 360 degrees to find the coterminal angle, which is 120 degrees.
So that's coterminal.
And the 120 degrees is right here. So this 120 degrees and 480 degrees, 480 degrees starts from here, goes all around the circle and lands at 120 degrees. So they end up at the same place. So finding out the cosine 480 degrees is the same as cosine of 120 degrees. Cosine, remember, is the x-coordinate. Is this small, medium, or large?
Small.
Small. And it's going left. So what do you have?
Negative.
Negative.
One
The
over
small
2.
size is 1 over 2. Okay, cotangent. Now 5 pi over 3, let's see what that angle is first. 180 degrees over 3. 180 divided by 3 is 60, so it's 5 times 60 degrees, which is 300 degrees. And 300 degrees is somewhere here. That's 300 degrees. Now, because this line is not slope 1 or negative 1, those are easy for the tangent or cotangent. Unfortunately, we will have to use the fact that cotangent is cosine over sine. So this value will be cosine of 300 degrees divided by sine of 300 degrees. Okay, so let's look at the cosine 300. Okay, judging from here, oh, this is not the reference triangle, sorry. This is the reference triangle. So cosine is the x, right? Small, medium, or large?
Small.
Small. And is it positive or negative? It's
Positive.
positive 1/2. Okay, sine 300. If one side is small, the other side must be large, right? So this
Negative
is,
square.
but it'll be negative because it's in the fourth quadrant. So do you remember this? All students take calculus. So in the fourth quadrant, cosine is positive, but both tangent and
Sine.
sine are negative. So you're going to have negative. Okay, how do you simplify a fraction if it has denominators inside? Multiply top and bottom by 2 to get rid of the 2's, and you get negative, pull a negative here, and negative 1/√3. Are we done?
No.
Still just a little more. What? Multiply square root of 3 top and bottom. What's square root of 3 times square root of 3?
3.
That's square root of 9, which is just 3, right? So you get square root of 3/3 as the answer. Okay, last, this is the most challenging, but it's not that hard. So let's just convert this to degrees to see what's going on. Pi is 180 degrees. Divide by 3, that gives you 60 degrees. So this is 11 times 60 degrees, which is 660 degrees. Oh, that's beyond 360. So what do? You subtract, again, to get the coterminal angles. And that gives you 300 degrees. Oh, okay, so that I know. 300 degrees is this one, right? Now, you have to say that this is therefore equal to 1 over, cosecant is 1 over sine. So you put 1 over sine of 300 degrees. Okay, and then sine 300 degrees is, well, we have it here. It's negative square root of 3/2. But don't read it like this. It's just a flip of, yeah. So I should just since this is sine 300 degrees, just flip it upside down. You get negative 2 over square root of 3, and once again you have to multiply square root of 3 top and bottom to rationalize the denominator. And if you multiply radical 3 top and bottom, the bottom will become 3. So that is the final answer. You need to know the following. I told you to memorize this important shape. If the hypotenuse is 1 and this angle is theta, what is this side? You get cosine theta, and this part will be sine theta, right? And there are two formulas that's very important. The first one is what? No, it's not that one here.
Cosine squared plus sine
Yeah,
squared.
cosine squared plus sine squared gives you 1 squared by the Pythagorean theorem, okay? What's another formula that you get from here?
Tangent plus sine.
Tangent of theta is
Sine theta.
sine theta over cosine theta. Very important. And accompanying this, because cotangent is the reciprocal of tangent, you should also know that cotangent is cosine over sine. So these will be the formulas that we use to find the values of other things. So solution of this, you start out by using that first formula. You say cosine theta squared plus 3/4 squared equals to 1. Okay? And you have to know that cosine squared with 2 in here, it has the same meaning as this one. This is just a shorthand for this. Okay? So if you don't know that, you might get confused, right? So it's cosine theta then squared, sine theta squared equal to 1, but sine theta is 3/4, so I plugged it in here. That's the equation I get. I just solved this for cosine, that's going to give me the cosine, right? So let's write this further. Cosine squared theta. What is 3/4 squared?
6/8.
Yeah. Oh, I just realized there's a typo that I forgot to correct. This should be
Negative,
minus because
yeah.
in quadrant 3, all students take calculus.
That's good.
Yeah, has in quadrant 3 sine is negative. Only tangent is positive.
Right.
Cosine and sine are negative. So this should be minus. But negative doesn't do anything if you square it, it's still positive. So what do you get again? 3 squared?
9.
9 over
16.
16 equals to what? How do you solve this? You multiply 16 everywhere,
Oh, yeah, that's right.
so that this 16 goes away and you get just 9. And 1 times 16 is 16, right? So you multiply 16. And it's beautiful because we don't have any fractions, so we like that, right? And then
Fractions.
you subtract 9, you get 7, and you get cosine squared theta equals to 7 over 16. And this is quite straightforward, but now here's another problem. How do you extract cosine from here?
Square root.
You take the square root. But whenever you take the square root, make sure you remember that you need a plus or minus square root of 7 over 16, right? So whenever you say something squared to another number, you put plus, minus, and square root. So we don't know if cosine is positive or negative just from looking at this, but we do know it from the fact that theta is in quadrant 3. So which one is it? Positive or negative? It's negative because only tangent is positive. Sine and cosines are negative, right? So cosine is negative, so we know that cosine is going to be the one with the negative, and then you can take the square root top and bottom separately. So you get square root of 7 on top. What's square root of 16? 4. 4, right? 4 squared is 16, so square root of 16 just gives you 4. Okay. And that's actually the most complicated part of this. Everything else then just follows. It's not that bad, okay? So let's try tangent. Tangent theta is sine over cosine, so it's negative 3/4 over negative square root of 7 over 4.
Jesus.
Hmm?
It's
Okay, now what do you do?
Multiply by the
Multiply top and bottom by 4, right? So that gets rid of this, and then minus minus cancels. So you end up with 3 over square root of 7. Are we done? Is that the
No.
answer? No. You still have to rationalize the denominator by multiplying by square root of 7 top and bottom. So that's your tangent. What is cotangent then?
1 over tangent.
Yeah, and you just have to flip this one, but it's easier to flip this one than this one. If you flip this one, then you get a square root at the bottom. But if you flip this one, you get the square root on the top, so it's easier. Okay, what's remaining now?
Excuse me.
cosecant.
Cosecant and secant, right? Okay, so cosecant,
Is 1 over side.
that's a flipping of the sign, so you flip this upside down, you get negative 4/3. And secant of theta is,
1
you
over
take,
side.
yeah, you take this one, you flip upside down, it's negative 4 over square root of 7. Again, you have to multiply square root of 7 top and bottom, but we've done this enough times, so you probably know what the answer is, right? If you have something square root of something, then that just becomes without the square root, but with the extra thing appearing on top. Okay, so that's how you do this one. Okay. If cosecant is given, then
You have sine.
the easiest one to get is the sine, because cosecant is the reciprocal of sine, and therefore sine is the reciprocal of cosine. You get that? So sine is the reciprocal of 5. Think of 5 as 5 over 1. So if you flip upside down, what do you get?
1 over
1 over 5. So you get that. But then once you get sine, we're in business, because if you have sine or cosine, you get the other by using this equation, right? So we put it into this equation and say cosine squared of theta. Cosine is the unknown, so I leave it like that. But then sine can be replaced by 1/5. That is being squared, right? And that has to be equal to 1. That's the equation. How do you square a fraction? You square both top and bottom. So you have 1 squared, which is 1, over 5 squared, which is 25. It's equal to 1. And then you multiply 25 to get rid of the denominators. So this denominator will be gone because I've multiplied 25 both sides. And the rest is straightforward after that. Subtracting 1 to the other side gives you 24, and divide, it gives you 24 over 25. And knowing that cosine squared theta means cosine with the square, how do you get rid of this square? If you get rid of this square, what happens on the other side? It's plus or minus square root of 24 over 25. I put plus or minus because we don't know if it's going to be plus or minus just from this equation. But from this condition that theta is in quadrant 2, I know what the sign of cosine is. Is it plus or minus?
Minus.
Minus. So we then say cosine theta is negative of square root of 24 over square root of 25. Square root of 25 is 5. And while I don't think I'm going to take points off if you don't do this next step, but it's always a good practice to find any square factors and bring it outside. So, for example, 24 is 4 times 6. 4 is 2 squared, so that can come outside the square root as a 2. So that's going to be 2 times square root of 6 divided by 5. Okay?
You give us bonus if we do that.
No. It's something that you should be able to do, right? Okay, so now let's find out secant. What's secant then? You flip that. It's a reciprocal of cosine, so you flip it, it becomes 5 over 2 square root of 6, which now requires that you multiply square root of 6 top and bottom to get rid of the square root in the denominator. And because this becomes 6 and this is 2, you get 12 in the denominator, and on the top you get 5 square root of 6. Okay, I don't have room for tangent, so let's do it here. How do you do the tangent? Sine over cosine. So, because sine is 1/5 and cosine is negative square root of 2 square root of 6 over 5, let's first move the minus out and then multiply 5 top and bottom to get rid of the 5 in the denominator. So that's what I get. So maybe I should put 5 here. I'm multiplying 5 top and bottom so that these are gone. That's what you get. You multiply square root of 6 top and bottom, so you get square root of 6 over 2 times 6, which is 12. Okay, then finally cotangent is the flip of this, but flipping this introduces a square root again. You don't want that. Instead, you want to flip this one so that you get 2 square root of 6 over 1, but dividing by 1 doesn't do anything, so that's the answer. Okay, number 7 is tangent 135 times cosine 225 positive or negative. And this is just a simple question about knowing this fact. Okay? So where is 135? 135 is here.
It's negative.
So tangent 135 would be negative. Again, all students take calculus. 225 is over here.
That's negative.
And here, only tangent is positive, sine and cosine are both negative, therefore cosine 225 is negative. So what happens if you
Positive.
multiply them? Product is
Positive.
positive. So that's the answer. Okay. And that's good enough explanation. Okay, so let me first explain this weird notation. This is the interval from negative pi to pi, including the endpoints, right? And this fork-like thingy, that means in. So x is some number inside this interval. That's what it means. Another way to say it would have been x is between negative pi to pi. Okay? Okay, so let's try to solve this. You have 2 cosine of x minus 1 equal to 0. You add 1 both sides, so you get equals to 1, and divide by 2,
Goes on.
1/2. And that means you're trying to locate the angles that give you 1/2 as the cosine. So go to the unit circle, and remember that 1/2 is the small size, right? We talk about small, medium, large. Small size is 1/2. And because it's in the x direction, we think about the small size 1/2. And try to construct a reference triangle that would have this as the base. Okay, so there's one here. This triangle will have this as small and that as large. Do you agree? Okay. What is this angle?
60.
It's the 60-degree one, right? Because it's 30, 45, 60. It's the 60 one. So I know that one answer will be 60 degrees. But then there's another one. Which one?
300.
The one that goes down, right? Which is 300 degrees. Except that your x has to be between negative 180 degrees to positive 180 degrees. So you can't talk about this as 300 degrees. What is it? It's negative 60 degrees. Right? You're going this way by 60 degrees. Right? It's the same 60 degrees, but you're going that way. So I know that the x should be 60 degrees and negative 60 degrees, except that because your interval is given in terms of radians, you have to convert 60 degrees to radians. So what is 60 degrees to radians? This is 180 degrees divided by? No, I mean, 60 degrees is 180 divided by?
2. I mean 3.
3, yeah. So this is going to be pi over 3, right? So that negative 60 degrees would be negative pi over 3, and therefore the answer is pi over 3 and negative pi over 3. Okay, so, I mean, if you know the unit circle well, these are easy questions. If you don't have the picture right, if you don't know how to read the correct picture, then these will be very hard. Okay, let's go to the next question. 4 sine x plus 2 radical 2 equals to 0. 4 sine x is negative 2 radical 2 if you move this to the other side, and then you divide by 4. Can you simplify this? What do you get if you simplify this?
Negative
2 and 4, they're both even numbers, so you divide top and bottom by 2. What do you get? Negative
radical 2.
square root of 2 over 2. Oh, I recognize this number. What is that? That's the medium size, right? And then on the unit circle, because sine is the y value, you're going down, and it's a medium size one. Remember, the small size is 1/2, so it should be right in the middle. And it should be something like here, and then, so it'd be small, medium, and large. Okay, so we're looking at this one. Okay. So now you think about angles whose y-coordinate will be same as this one. You have a point here, and you have another point there. They both have y-coordinate as this. So you draw it, And you should also know that for the medium size, the reference angle is always 45 degrees. This angle to the nearest x coordinate, that's called the reference angle, and that's just 45 degrees if you have the medium size one. Okay, so knowing that it's 180 degrees plus 45 degrees, what is this in terms of degrees? 225. And this is 270 plus 445, which is 315. Okay. But you could do that and then convert that to radians, but it's good to just memorize these radian measures as well. I'm pretty sure some of you know the value. What is this in terms of radians?
Something pi over 4.
It is. It's one of the pi over 4
4
family, but what is it?
5 pi over
5 pi over 4. Good. And this is 7 pi over 4. Right? Because it's like 1, 2, 3, 4, 5, right? And 6 and 7. Right? Okay, so now the answer is clear. X equals to 5 pi over 4 and 7 pi over 4. Okay, part C is a bit more tricky. This one is saying that you have an angle that's going this way, which passes through the point negative a comma 6, and it's asking you what sine theta is, what cosine theta is, what tangent theta is, and all that, right? So how do you do this? Well, first, what you do is you draw this reference triangle, and because this is 6, this length is 6, and this is 8. Right? And because this angle is in the second quadrant, remember that sine is positive and cosine is negative. Also, is take calculus, sine is positive. Right? And then now, usually I just say, well, the x-coordinate is the cosine and y-coordinate is sine, but that doesn't make sense here because these values are above 1, or the absolute values are bigger than 1. The sine cosine can't have numbers bigger than 1, so that can't be. So instead, what's really happening is you're trying to figure out this location where this ray is going to hit the unit circle. Okay? And there's a way to do it that way, but an easier way is just to use SOHCAHTOA. Right? So just do the following. Ignore the fact that we're talking about this angle. Just think about the angle as this one, the reference angle. Okay? Because the reference angle and the actual angle, their values of sine cosines are the same, except for maybe for the sines. You know that, right? So see, sine 7 pi over 4 is same as sine 45 degrees, except that they have different signs. Okay? So you can ignore the fact that we're talking about this angle and just think about this angle. Right? So for this angle, what is sine? Sine is opposite over hypotenuse. Uh-oh, that means we need to figure out this length, right? How do you do that?
Pythagoras theorem.
Yeah, 6 squared plus 8 squared is the hypotenuse squared. 6 squared is 36. 8 squared is 64. What's that?
100.
100. So what's h? H must be square root of 100, which is 10. So I have this as 10. And now you have sine theta as opposite over hypotenuse, which is 6 over 10, which is 3 over 10.
Over
5. 5. And then cosine theta is 8 over 10, but with a minus sign, because it's in the second quadrant. Remember, cosine is negative. And that, if you reduce this, negative 4 over 5. Okay, and then tangent theta is sine over cosine, so 3 over 5 over 4 over 5 with a minus sign. Yes?
What if we just do opposite over adjacent?
Oh, you can also do that as well. You can just do opposite or adjacent. Yeah, maybe that would have been quicker. Okay. But if you multiply 5 on top and bottom, you get negative 3 over 4. If you did opposite over adjacent, you get the same thing. Just remember that tangent is also negative. Only sine is positive here. And once you get these values, now you just take the reciprocals and write down all the values. So cosecant theta would be the reciprocal of 3 over 5, so it's 5 over 3. Secant of theta is, what is secant of theta? Which is negative 5 over 4. And then cotangent theta is? Yeah, negative 4 over 3. 5 over 5, yes. How do you do it?
180 over pi.
You multiply 180 degrees over pi to convert to degrees, right? So pi cancels, and if you do 180 divided by 5, you get 36, and then this gives you 144 degrees. Okay, on the other hand, well, I already know the answer, which is this one, but let's just do the calculation anyways. How do you convert degrees to radians? You multiply pi over 180 degrees, and then that means degrees cancel, you get 144 pi over 180.
Which is 4 pi.
And then it ends up being this one, but you have to reduce. So you have to divide top and bottom by 12, you get 12 pi. 180 is 12 times 15. And then because you still can divide top and bottom by 3, you divide top and bottom by 3, you get 4 pi over 5, which is the original. Okay, so let's think about 8 pi over 5. What's the reference angle? And it's hard to picture what this is doing, so please change to degrees first, and then draw it on the unit circle. And after you figure out the reference angle, you have to go back to radians, right? So pi is 180 degrees, and then 180 divided by 5 is 36. So this gives you 288 degrees. And on the unit circle, what that means is here's 270 degrees, right? And 288 is just slightly after 270. So now think about where the reference angle is. Reference angle is the closest angle to the x-axis, so this is your reference angle. So how would you get your reference angle then? This is 360, and you want to know what this difference is, right? So you would do 360 degrees minus 270 degrees, which is, no, sorry, 288 degrees, which is equal to 2 and then 72 degrees. And this is twice of 36 degrees, and I know that 36 degrees is pi over 5. So the answer is 2 pi over 4. Yeah, I just did this quickly, but you would just simply multiply by pi over 180 to convert into radians, okay? Yeah. All right, so this one, this is huge. I don't know how to convert this. So what should we do? You just keep adding 360 until it becomes positive, right? So 360 times 2 is 720, still under. If you double 720, you get 1440. That's slightly over this, right? So you're going to add 1440, which is slightly over this one and still 4 circles, right? So you're going to get, what is this then? 6 degrees, and then 16, and then 116?
Yes.
Yeah, 116 degrees. Okay, where is that? Here's 90 degrees. 116 is right after 90 degrees, so here's 116 degrees. Therefore, what's the reference angle? 180 degrees minus 116, which is 64 degrees. Done. Question. You want to use SOHCAHTOA, and then to find A, for example, see 8 is given and this angle is given. So think about how to use A and this angle. Well, A is the opposite of this angle. A is the adjacent. Which of the 3 trig functions give you opposite? It's the tangent one, right? It's the tangent of 32 degrees equal to 8 over A. Multiply A both sides. And then you divide by tangent 32. And you just punch this into your calculator. 12.8. And same thing with the B. What should I do for B? Sine or cosine?
Since you have both sides, you could.
Oh, you could use this one. Yeah, you're right. But it's easier to use 8, right? So let's use 8 and B, which gives you sine, right? Sine 32 degrees is equal to 8 over B. Again, multiply this over here, and then you divide, and that's going to give you B equals to 8 over sine of 32 degrees. Did anyone actually calculate? 15.1. Make use of the following. We said that cosine squared theta plus sine squared theta is 1, right? So here's a tip for handling questions like question 19. If you see cosine squared theta, replace it by 1 minus sine squared. Because after all, if you move this to the other side, cosine squared is the same as 1 minus sine squared, right? If you see sine squared of theta, then you replace by 1 minus cosine squared theta. So that's about it. And that's going to take care of actually the second question. A is quite simple. So 19A, let's start with this. Cotangent theta, sine theta. Okay. Another tip is to change to sine and cosine if you see something else. So cotangent is what over what? Cosine over sine. Right? Can you simplify this?
Cosine.
These cancel. And the answer is cosine. Oh, very simple, right? That's it. That's all. Now B has sine theta cosecant theta minus sine theta. Okay. Suggestions. What should we do? Try to change everything to sine and cosine. So what do?
Cosecant is
Would be 1 over sine. Yes. Now multiply them, expand, right? And if you multiply anything by its reciprocal, what do you get?
Answer is negative sine.
You get 1 times 1 over sine gives you 1, right? Then what's 1 times sine times sine? Sine squared. Okay, now you already know the answer. This is same as cosine squared, right? So that will be the answer. But if you didn't know that, you can do the following. I see a sine squared. So what am I supposed to do? Write it as 1 minus cosine squared theta, right? And then if you multiply the minuses out, you get minus 1 plus cosine squared theta. So 1 minus 1 cancels away, and you get cosine squared theta. Done. And the question also says, simplify so that it's not a fraction. So here you actually have to, rather than putting everything in terms of sine or cosine, you want to change everything to cotangent, tangent, or whatever, okay? To make it not a fraction. Okay, so here's a simple idea. You can split this fraction into one fraction minus another fraction, and I call this share the love. Yeah, share the love. Right? Some of my math 80 students remember. Okay, so it's this. So you write it as cosine squared theta over sine theta cosine theta minus sine squared theta over sine theta cosine theta. All right, simplify this. How can you simplify this? One of the cosines will cancel one of the cosines. So you get cosine theta over sine theta. What about this one?
sine.
One of the sines will cancel this sine. You get sine theta over cosine theta. Okay, so we know what this is. This is cotangent theta. What's this? Done. That's the answer.